Hi everyone, today our group, which consists of 5 members, including me, YEOW, Sean, Sam, Jinwei, and Frederick, are going to talk about the diodes. So firstly, I will pass to Sean to bring us more deeper into the understanding of diodes.
Hi guys, I'm Sean. I will start off our topic for today by briefly explaining what's a diode. A diode is a device that allows current flow in only one direction. A diode is created from a p-n junction which is formed when a p-type material and n-type material join together. P-type materials consist majority of holes, while n-type material consists majority of electrons. When p-n junction is formed, diffusion occurs. Electrons from n region give up energy and drop into a hole near the junction, leaving a hole behind which forms a layer of positive charge. While holes in p region fill up by electrons from n region, it creates a layer of negative charge. These layers form a depletion regions. Depletion region establish equilibrium when electron from n region is repelled from p region. In the depletion region, there are many positive and negative charges on opposite side of the p-n junction. This causes a field of forces which is called electric field is formed. This electric field is a barrier to the free electron in n region, causing electron require more energy to move through the electric field. The potential difference of electric field across depletion region is the amount of voltage required to move electron through the electric field. This potential difference is called barrier potential with unit of voltage. The amount of voltage required is not constant and it depends on the type of materials, amount of doping, and temperature. Next, I'll pass it to YEOW to continue our topic for today.
Hi, I'm YEOW, so I'm going to talk about forward bias. So forward bias is a condition that allows current through the p-n junction. The negative terminal of V bias is connected to the n region, while the positive terminal is connected to the p region. When forward bias is applied, the positive terminal of V bias repels the holes in p region towards the depletion region and causes the negative ions to reduce. On the other side, the negative terminal of V bias repels the electron in p region towards the depletion region and causes the positive ion to reduce. The reduction of positive and negative ions causes the depletion region to narrow. When forward bias is applied, the free electrons are provided with enough energy from the bias voltage source to overcome the barrier potential and effectively climb the hills and cross the depletion region. The energy that the electron require in order to pass through the depletion region is equal to the barrier potential. In other words, the electrons give up an amount of energy equivalent to the barrier potential when they cross the depletion region. Alright, so now I will pass to Frederick to talk about reverse bias.
Hello guys, my name is Frederick. I will barely discuss about the reverse bias. Reverse bias is a condition that prevents current through the diode. Voltage source or bias connection are negative to the P materials and positive to the N materials. When reverse bias voltage is applied, positive side of bias pull the free electron in the N region away from p-n junction, cause addition positive ions are created, widening the depletion region. In the p region, electron from negative side of voltage source enter as valence electron and move from hole to hole toward the depletion region, then created additional negative ions. As the depletion region widens, the availability of majorities carries decrease. For reverse current, small number of free minorities electron in p region are pushed toward the p-n junction by the negative bias voltage. Electrons reach wide depletion region, they fall down the energy hill, combine the minority holes in n regions as valence electrons, and flow toward the positive bias voltage, create small hole current. The conduction band in p region is at higher energy level compared to conduction band in n regions. Electrons easily pass through the depletion region because they require no additional energy. Next, I will pass the discussion to Chun.
The part of voltage current characteristic of a diode. For VI characteristic forward bias, first condition, the voltage supply increase in constant rate. First of all, the current increase slowly until the need called barrier potential. This is because minority of electron flow on it. Value of barrier potential depend on the type of diode. After the barrier potential, the current slightly increase due mainly to the voltage drop across the dynamic resistance. Then the current increase rapidly because the free electron enough energy to climb the hill and across the depletion region of diode. Then for the VI characteristic reverse bias, first of all, the current increase slowly until the need called breakdown value. After this point, the reverse voltage remains at approximately breakdown value, but current increase very rapidly, result in overheating and possible damage the diode if the current is not limited to a safe level. Breakdown value also depend of type of diode. Thus, the complete VI characteristic curve. When at the normal temperature condition, the graph will flow behave like this for the forward and the reverse. The graph will be affected by temperature. For the forward part, the forward current increase, but the forward voltage decrease, and the bearing potential will decrease. The bearing potential will decrease 2 mV for each degree increase in temperature. Then the graph will flow like this. At the reverse diode part, the temperature increase, the reverse current also increase, behave like forward. The difference just the value, breakdown value remain approximately same and can be usually be negated. Then the graph will flow like this. Then I pass to Sam to talk about diode models.
Hey guys, now I want to talk about the diode models. First is the ideal diode models. It is a simple switch with forward bias for closed switch and reverse bias for open switch. The barrier potential, forward dynamic resistance, and reverse currents are neglected. Therefore, the forward voltage and the reverse current is equals to 0. The reverse voltage is equals to the bias voltage. While forward current can be determined by Ohm's law, which is forward current is equals to bias voltage over resistance. Next is practical diode models. It is formed when barrier potential is added to the ideal switch model. The resistance dynamic is neglected. The diode assumed to have a voltage across it when forward bias, which is 0.7 volt for silicon and 0.3 volt for germanium. The barrier potential does not affect reverse bias, so it is not a factor. Forward current can be determined by Kirchhoff voltage law, which is bias voltage minus forward voltage minus voltage across resistor is equal to 0, and Ohm's law, which is forward current is equals to bias voltage minus forward voltage over resistance. The diode is assumed to have a 0 reverse current, so reverse current is equals to 0 and reverse voltage is equal to bias voltage. Lastly is complete diode model. The complete diode model consists of barrier potential, small dynamic resistance, and large internal reverse resistance. Reverse current taken into account because it provides a path for the reverse current, which is included in this diode model. When forward bias, it acts as a closed switch in series with barrier potential and small dynamic resistance. When reverse bias, it acts as open switch in parallel with large internal reverse resistance. Diode assumed to have a voltage across it when forward bias, since barrier potential and dynamic resistance are included. This voltage consists of the barrier potential voltage and the small voltage drop across the dynamic resistance. The curve in the graph slope because voltage drop due to higher dynamic resistance as current increase. Reverse current is indicated by the portion of the curve to the left of the origin of the graph. So, the forward voltage for a complete diode model is 0.7 volt minus forward current times dynamic resistance, while forward current is equals to forward bias minus 0.7 volt over resistance plus dynamic resistance.